Today we are going to discuss about basic image processing techniques. Basic image processing techniques. Okay. Before going to show you the code implementation, let me tell you brief discussion where exactly these image processing techniques are helpful. In traditional ML algorithms or machine learning algorithms, in order that to feed this data, we have to extract features manually. It means someone should know the domain knowledge and they have to extract the features from the images. Suppose in our image data set, a image contains several features. Okay. To extract those features, these basic image processing techniques will be helpful. Okay. Now coming back to in what sense? Maybe you want to extract each pixel. Okay. Or in other way, you just want to take the average values from, suppose I have a image, this is only one channel image, let it be, and I want to take the average values of each and every pixel for a 3x3 kernel. Okay, that means from this original image I will keep a 3x3 kernel like this at a particular single pixel 1. Now I will find average value so that I will get another image where each pixel is obtained by this particular average value. Now what happens? Every pixel has a new feature. Every pixel of this particular image has a new feature. All these things will come under image processing techniques only. Okay. This is where the importance of image processing techniques will come in machine learning problems. Now coming back to deep learning problems, especially for on images where suppose in deep learning there is nothing like manual feature extraction. Features are extracted while training goes on by default by the model itself. So what are the requirement of image processing techniques here? Suppose let us take some VGGNet model, RESNet model. Maybe you don't know what these are, but not necessary. Just imagine that there are some models in deep learning, especially in CNNs models. Likewise, several models will be there. Now, how they expect image data means they want image data to be in a particular format. Okay. Suppose I have images some around 1800 cross 1400. This is the size of the each and every image, or some 1800 cross 1300 or 1200 cross 400. Maybe suppose I have some 100 images in a particular data set, and each and every image consists of these sort of dimensions. Individuals, they have unique dimensions. But end of the day, if you want to feed these kind of entire data into particular DL model, every image should be in a particular size only. Okay. Suppose this model accepts input in the form of 224 cross 224. So what happens? Before feeding this entire image data or each and every image into this particular model, you just have to resize each and every image in this particular entire training data to the size of 224 cross 224. 224 cross 224. Okay. This is one such case of necessity of or requirement of image processing technique, that is nothing but resize operation. Okay. Now coming back to in one more case I will tell you. Suppose in DL models are very much hungry of data. In the sense, in order that the model to be performed well, they need lot of data, lots of data. Okay, but we have only one such sort of data. Okay, suppose I have one image. Suppose maybe you have some 100 images in a particular given training data set, but I want to increase this entire data to some 1000 data sets, 1000 images of data set. Okay, so what should I do? I will take a single image and I will do several image processing operations on this particular image alone, and I will generate new images out of it. Okay, at that point of time also, basic image processing techniques will help you. Basic image processing techniques will help you. Out. Okay. One operation is, maybe I have rotated each and every image. Suppose one image is like this, and I want to rotate the image to 25 degrees, some 30 degrees, like 40 degrees. Likewise, one such operation is rotation. Okay. And the same image, I want to increase the brightness up to some other value. Brightness 1, brightness 2, brightness 3. Okay. Or also, I want to do some spatial operation, spatial filter operation. Likewise, in summary, I can say that in machine learning and deep learning problems, basic image processing techniques are very much helpful in order that the model to be performed well. That is the whole summary. Okay. The entire lecture has been divided into 3 parts. First one is some basic modifications. Like resizing operation. Suppose image is having large size, I want to reduce it to some smaller sizes. Second thing is rotate. I want to rotate the image to a particular degree. Okay. And one more thing is, I want to transpose the image. End of the day, image is nothing but a matrix only. Transposition of a matrix in another way. All these operations come under basic modifications of image processing. Second thing is enhancement techniques. Okay. Third thing is spatial filter operations. In this lecture, I will discuss 3 things. First one is basic modifications. Second thing is enhancement operation. And the last thing is spatial filter operation on the given images. I will show you through the code how exactly to do it later on. Before that, let me give you a brief introduction. Usually in Python, we have several image processing libraries are available, like scikit image. Scikit image is one such library. Second thing is matplotlib. Matplotlib is for even to extract some information from the image, at the same time to visualize the image also. Okay. Third thing is Pillow, one such library. Next thing is Opencv. This is one such library. Okay. So keep in mind that end of the day in Python, there are several libraries that are available for us to do basic image processing techniques. Okay. That is the final summary. But here in this lecture, I mostly focus on Pillow. Okay. Using Pillow library, let us see what sorts of operations are to be done or can be done. Open the drive, Google Drive. See here. Here I have downloaded some chest X-ray data set. Okay. Here, if you observe, the original image is this one. This is the original image. I have downloaded this one from Kaggle chest X-ray dataset that is available like KA chest X-ray images pneumonia. This is around some 2 GB data is available. I have downloaded that data and I have started using those images to explain this entire processes. Like suppose this is what the original image looks like. So what happens is I have loaded this image and I have done some basic image processing operations and I have saved them back to these files, like rotate the image, resize the image, transpose the picture, cropped picture. Let me show you. As I have already told you, see here, you just have to, in order that to use a Google Colab file, you just first go and use this mount drive, Google Drive. Later on, here you just have to go through this, running this code. I will just explain what are the operations are available. See here, we are using Pillow library here. From Pillow or PIL, we will import image. Later, you should give a particular correct path to whichever image you load here. Okay, that is very much important. All the remaining steps are okay, not that difficult. So what happens is, I just loaded this image. See here, and I have shown the image here. See, this is very large image. Okay, let us see in which format the image is, like JPEG format here. Similarly, L indicates only one channel. Next thing is type of image. It is a image file class where from in Pillow library provides image module. Just import that one image. That will help you to load this image JPEG file. Next thing is I just want to extract what is the height and width of the image, so that we will get to know the size of this entire image. See here, width and height, image size. It is having some 1858 to 2090, very huge image actually. Okay, so usually the CNN algorithms, whatever we use later on, all of them will expect the input data somewhere around some 224 to 224, 512 to 512, 256 to 256. Likewise, okay. So the first operation I will discuss is resizing operation. This image contains 1858 to 2090. 1858 to 2090. Now we want to resize this image to some 256 cross 256. Similarly, 512 cross 512. Okay, this operation can be done using this code. Just go through this code, you will get to know easily. Now image has been resized. See here, from this image to this image, you can see here. After doing this operation, you can even directly go and save this one. Okay, here using this code, actually I have commented out, just uncomment that line, and you can save wherever you want to save this line. Giving this particular path is very important. Other than that, everything else is simple only. See here, after saving this one, you can see here resized picture. See, original image is this much size. I have just modified it to 256 cross 256. That is one first operation. Now let us get back to another operation, rotation operation. See here, using image underscore resize dot rotate. We are using rotate here. You can directly rotate this image. They have given something like 90 degrees. See, if I keep this image in 90 degrees, rotate will be given like this. And I have saved this file also here. See, rotate a picture. Okay. Now, that is rotation operation. Even you can keep like 45 degrees or 60 degrees or 70 degrees, whatever you want. All these things will be helpful in data augmentation. Now coming back to cropping the image. Suppose I have this huge image of 256 to 256 length, but I want to extract a particular portion from this image. At that point of time, you will get to know, you will see the help of cropping an image. Okay, very important. See, from this entire portion, I have just taken out this 128, 128 part from here to here, and it has been saved as another file. Okay. what we have seen. First one is resizing, second one is rotation, third one is cropping. Now let us get back to transpose of the image. You can see here transposed picture. This is how the transposed picture will be look like, whereas the original picture will look like this. Okay, this is 90 degrees rotated image. These are the few basic modification operations are done here. Okay, now coming back to, now let us get back to image enhancement module. Okay, in the first case I just wish to increase the see here, two images have been loaded, 256 cross 256 and 512 cross 512. In pill image, in pill, from pillow you can download, import image class. Later you can display here, it is having a size of 512 cross 512, and I want to enhance the image now. Enhancement can be discussed in four ways. First of all, increasing the brightness, another one is color, contrast, and another one is sharpness. Okay, all these operations are applied on the given image. See, for example, image enhancement module. Suppose this on the left side you can see the original image. After increasing the brightness, this is how it is looking like. You just have to, here we have something like image enhanced module has been imported from pill. Image enhanced brightness of image input. Okay, if you change this value, new brightness value, accordingly this particular brightness will change. Okay, you can play around with this one, that's not that difficult. Next thing is color class. You can see this is how the output looks like. Similarly, contrast class. Okay, contrast, this is another image enhancement operation. Here also we have something like image enhanced contrast. See here, image enhanced color. See here, image enhanced brightness. Color class, contrast class. See here, original image looks like this in the left side. This is how contrast enhanced image looks like in the right side. Next, coming back to sharpness class. See how the output looks like. See, this is left side image, original image, and right side image is sharpened image. This is how the image enhancement operation works. Pillow provides 4 classes. In summary, I can say that brightness class, color class, contrast class, and sharpness class. Based on your requirement, just apply this code onto the data, whatever data you have, so that you will see these details. Okay, sharpness, color enhance, contrast enhance, color class, and brightness class. That's it, nothing else. All these operations come under image enhancement operations. Okay, now let us get back to spatial filter operation. Okay, image filter in Python using pillow module. Suppose I want to blur the image, it can be done using blur class, box blur filter, similarly Gaussian blur filter and median blur filter. Just check out how the outputs looks like in each and every blur. See here, original images look like this. With the radius of 1, this is how it has blurred. With the radius of 2, it has, the blur operation has been increased more. Okay, see here, the filter that is used is this one. Maybe the image size may be different. Here we have taken some 256 cross 256. On this we are using here 5 cross 5 kernel. This is how the output looks like. Okay, next thing is, suppose if we apply Gaussian blur filter, this is how it looks like. See, with radius 1, it is output looks like this. With the radius 2, output looks like this. Now get back to median blur filter. Check out here. This is median blur, Gaussian blur. This one is box blur, and another one is blur. Okay. Just you apply this code, it will give you for your particular data. That's it. There is nothing else to discuss more. This is for sharpening. You can keep this filter value, automatically can be applied. Okay. Now coming back to contour, it will help you to detect the edges in an image. Okay, let us see how it helps. See here the code. Contour, just see, it detects the edges. This is the input image, and the right side image is edge detected image. Okay. Now get back to detail filter. Detail filter enhance the details in the image. Okay, see here, but the filter name is dot filter of image filter dot detail. Likewise, we will apply based on our requirement edge enhance filter. See here we have detected the edges. Here it has clearly shown the edges. Enhance the details in the image. See, using contour filter, just we have detected the edges. But in edge enhance filter, you can see clearly edges are highlighted more, and you can visualize well. Okay, that means the details of the edges have been enhanced. Similarly, you can go for edge enhance more filter. Next, Emboss filter. You just go through the code, just load the image of your particular image, just made some changes and get the output and see. Based on your requirement, suppose if you want to use this filter and use this, otherwise just ignore. Find the edges in a filter. See here, this is the original image, detect the edges using find underscore edges filter. The summary is, I have several filters there are several filters present in Pillow library, and you just have to use a particular filter based on your requirement. And for that one, particular code is already available. You just have to load the path of the particular image correctly. Everything will happen later on. Now coming back to sharpen the details. See, sharpen filter also more or less equal to enhancing the edges information only. Okay. In summary, I can say that edges indicates the high frequency components in an image. That means we are enhancing the high frequency components. Okay. Next thing is smooth filter. Original image, noise removed from the image. Okay. Next thing is smooth more filter, unsharp mask filter, kernel filter. Kernel filter works in such a way that you can give the kernel value. In these, all the remaining things are like unsharp mask filter. These are by default things. Unsharp mask, image filter dot unsharp mask, smooth filter. See here, image filter dot smooth more. All are by default modules. These are all by default filters. Whereas if you want to use kernel filter, you can design your own filter here, and you can apply that particular kernel on this particular image, and you can see the output. See here, original image is on the left side. On the right side, kernel applied image. See, when it comes to edge detector, the applied filter is 1 0 minus 1 0 0 0 minus 1 0 1. This is the kernel thing, that is up to 3 cross 3 size. See, this is how it has detected the edges. Edge detector 2. This is how it has detected the edges. Likewise, in summary, I can say that. I can say that depending upon the requirement, you just have to find out the particular library. Okay. Suppose in our case, we have used Pillow library. Using Pillow library, we have loaded the JPEG format related images. Okay. After loading that particular image, we have done some basic modifications like resize operation, rotation operation, transpose operation, all that stuff. Next thing is enhancement operations, where we have focused on brightness increment, similarly contrast increment, okay, and sharpness, such operations. They work mostly on intensities. And the last thing we discussed are basic filtering. Okay. Suppose if you want to detect the edges in the image, you just have to go through a particular filter and apply that filter on the image. code is already available. You just have to go and load your image and use that filter depending on your requirement. Next thing is, even in filters also, some default filters are there. Otherwise, you can design your own kernel and apply that image. This is the final summary. In short, I can say that always basic image processing techniques are the fundamental step in any of the machine learning or deep learning problems, especially when you deal with images. That is the final summary. Thanks a lot.